So, with activity 3, they say we have a 12-sided die. If we have a 12-sided die, this is what we expect. We expect to have 12 possible outcomes. It's either we can get 1, we can get 2, we can get 3, we can get 4, 5, 6, 7, 8, 9, 10. Now, we can also have a 6-sided die. If you have a 6-sided die, it means you expect the numbers from 1 to 6. But this one, it's a 12-sided die. So if you have this 12-sided die and then they speak about the following, then they say we should do the following with this 12-sided die. Number 1, they say which event A are the first 5 prime numbers. Yes. And then event B are the multiples of what? Of 6. Then they made it easy for us. They said first concentrate on A. Write down the set of A. Yes. And then you write down the number of A, and then you write down the probability. Let's go and talk about the prime numbers. What are prime numbers? As long as you know what are prime numbers, then you shouldn't have a problem. So prime numbers, you said it's a number that can go into what? It's divisible by 1 and itself. It only has 2 factors. It has 1 and 1 and itself. So who are those people who have 1 and itself? So I'm going to tell them we have A is going to be equaling to, these are the people who are going to be in A. The first one is what? Is 2. Who else is there? We can also take 3. We can take 4. 4 doesn't play on this game. We take 5.
7.
We take 7. And we also who? So what is this that we got here? These are the sets of A. Sets of A. You are going to give yourself a mark for the sets of A. So you have 2, 3, 4, 5, 7, and 1 and 11. What else did they say? They said which we should give them the number. Let's go and give them the number. How many are number of A? So I'm going to say N A. This is going to be given by 1 by 1, 2, 3, 4, 5. So the number of A is 1, it's 5. All in all, how many numbers do we have to choose from here? We have 12. So what is going to be the probability of A? It's 5 all over 12. And you can't do anything about this.
Yes.
Which will 5 all over 12. Or you can, if you wanted to do something, you could have written it as a decimal. That's the only thing that you can do. So we give you 1 mark, 1 mark, 1 mark. Okay, we're done with A. Next, what else do we have to do? We're going to be talking about okay, so we're done with A. The next thing they say, which is going concentrate on B. Now we're going to take everything back and then we're going to concentrate on B. We're going to take everyone back and then we start to talk about B. Let's go and check that. Who is B? So you take this one back, 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 and then you say set B. Now, what do they want for set B? They say they wanted. What do we want for set B? Factors of 6.
Yes.
Multiples of factors. So we want multiples of 6. What are going to be the multiples of 6? Multiples of 6 we have
6 and 12.
we have this person. We take them 6 and then the other one is what it. How would you get it? And then they ask us about the number. How many do we have?
2.
Number of B? It's 2. Probability of B is 12 over 12, which is going to be 1 over 6. Everyone is happy with this, right? There's no problem whatsoever here. Okay, now let's go and talk about the Venn diagram. They say we should show the actual outcomes. Now, if we are going to be doing the Venn diagram, we are going to erase everything and start with the Venn diagram. So, what is it that we should have in our Venn diagram? We should have a rectangular shape. So, I'm going to start with that. We are going to put everyone inside the rectangular shape. That's the first thing. And then we have event A and then we have event B. So, event A. Okay, let's start with A. Who are the people that are in A? Who are those people that are participating in A?
3.
We have 2.
3.
We have 3. 5.
7.
We have 7. We have 7. And then we also have 11. Come, 11, come. Oh. Come, 11. Okay, these are the people that we have inside here. Now you want to check A and B. You want to check if there's any intersection or A and B. You want to check if there's any intersection between A and what then and B. Now what is B? B is this one. So I'm going to make another circle for B. And then are the people that we need from A that are also supposed to be B? No. There's no one. So here we say this one is A. And then we tell them which this one is what is. Check the people that are supposed to be in B and put them there. So we have 6. And then we also have what? There's no intersection. Yes. We're not going to pass the intersection. What are we going to do with the rest of the people then? We're just going to put them somewhere. They should be somewhere, but not inside the circle. 10. 9. 8. And you see, I can put them anywhere outside the box. It doesn't necessarily mean which they need to be. Yes. And then 1. This one is showing the what then? The actual outcome. And then you can just say which here outside we have what? We have S. Any questions? All right, next. They say which we should write up. They say which we should show the number of outcomes. Same graph, we're going to show the number of outcomes. We show the number of outcomes. Let's start with A. How many do you see in A? The number of outcomes. So it means what you can simply draw exactly the same thing. But now we are going to draw it with the number of outcomes. So I'm going to tell them which A is 5, and then B is 2. And then how many doors are outside? It's 5. And then we have S. So what does this one represent? It represents the number of what of outcomes. The last one they say which we should show what? The probability. Again, exactly the same thing. A, B. So what is the probability? It's going to be this one. It's 5 all over 12. 1 all over 6.
Yes.
And then it's 5 all over 12. And then this one here is right there. Yes. And then we are done. We are going to do activity number